We are moving on to section 5.4, which is being able to identify types of reactions. All you'll have to do in this situation is identify the type. You don't actually have to predict what the results are going to be. If I give you the product or the reactants, you don't have to tell me what the products are supposed to be. All you have to do is say what categorize them to which type of reaction it is. Okay, so just as a summary, these are the 5 that we're going to deal with. These can actually be broken down into more specific types of reactions. However, in general purposes, these are the 5 that we're going to talk about. Combination, decomposition, single replacement, double replacement, and combustion. I'm going to talk about what's actually happening in each of them, but then at the very end I'm going to show you a shortcut to determine which is happening. The first one is combination reaction. You'll notice you'll have 2 things going into one thing. They're combining, they're synthesizing. There are actually 3 or 4 names for this, but we're going to use the term combination. So I'm just going to keep saying combine. They combine to have a single product. So it's 2 or more things on the left, 1 thing on the right. That's what you're going to be looking for. 2 or more, and then 1 on the right. 2 or more, 1 on the right. So here's an example. We have magnesium. And maybe you did this in your previous class where you burnt it, you lit it on fire, and you saw the smoke come up. Well, when that happens, it's burning an oxygen, and then it's producing magnesium oxide. It's producing a single thing, and that's the ash that fell on the ground. Alright, decomposition is the exact opposite. Instead of having 2 things on the left and 1 on the right, now you have 1 thing on the left and 2 things on the right. See, 1 thing on the left and 2 on the right. 1 thing on the left, 2 on the right. So to break it down, if you have 1 thing on the right, that's going to be combination. If you have 1 thing on the left, that's going to be decomposition. So an example of that would be mercury oxide, mercury 2 oxide. If we take it and we burn it, it's going to break up into its own elements. So it had 1 thing to begin with, and now it has 2, mercury and oxygen. Now single replacement. What's happening with single replacement is one element tries to replace another element that's in a compound. So for instance, zinc is all by itself on this one. Well, it's going to take the place of the hydrogen. So zinc is now with chlorine rather than hydrogen being with chlorine. And hydrogen's all by itself. So this situation, iron is going to replace copper. So that means iron is now going to be with sulfate, and copper is going to be by itself rather than iron being out by itself. So this time you're going to have an element and a compound. So, as a review, combination is 1 thing on the right, decomposition is 1 thing on the left, single replacement is an element and a compound on both sides. So if we look here, here's zinc, hydrochloric acid, but that zinc replaces the H in the HCl, so now zinc is with the chlorine rather than the hydrogen being with the chlorine, and hydrogen's all by itself. So here, we're talking about double replacement. Double replacement is when they both switch partners. So silver is no longer with nitrate, now it's with chlorine. Sodium is no longer with chlorine, it's now with nitrate. They've switched. Silver was originally with nitrate, now silver is with chlorine. Sodium was originally with chlorine, now it's with nitrate. Same with here. Zinc is going to be with chlorine now rather than sulfur. Hydrogen is going to be with sulfur now rather than chlorine. One dead giveaway is the fact that you have two compounds. So, compound plus compound is going to be a double replacement reaction. Sodium sulfate and barium chloride. The sodium and the chlorine are going to come together to produce sodium chloride. And then the barium and the sulfate are going to come together to create barium sulfate. They've essentially changed spots. And then the final one we're going to talk about is combustion. Combustion must have carbon in it. It absolutely has to have carbon in it. When it burns, you're going to light it on fire, and you're going to produce CO2 and H2O. Sometimes it doesn't burn perfectly, and there's some other products in there, like carbon monoxide instead of carbon dioxide, but for our purposes, it will always say CO2 and H2O. In order to have that happen, you have to have oxygen there. So some carbon-containing compound reacts with oxygen to form CO2 and H2O. So you're going to look for O2, CO2, and H2O when you're trying to identify it. Example here is if we have propane. Propane burns in oxygen. We're going to light it on fire, and it produces CO2 and H2O. Alright, here's some generic examples. Remember, combination, one thing on the right. Decomposition, one thing on the left. Single replacement is an element and a compound. For instance, right here we have an element and a compound. Copper is an element because it's not worth anything else. Silver nitrate is a compound because it's more than one element. Double replacement is compound and compound. You have a compound here because it's more than one element. You have a compound here because it's more than one element. There's two compounds. And then finally we have combustion, which is CO2 and H2O. CO2, H2O. That's how you remember which types of reactions things are. So let's do some practice. We have an element here and a compound. That means that's going to be a single. You have a compound here because you have more than one element bonded together. You have another compound because it's more than one element bonded together. That means it's double. We have an element here because it's only one thing. And we have a compound here because it is more than one thing bonded together, more than one element bonded together. That means it's single again. And then finally we have CO2 and H2O. That means it's combustion. Alright, so we have barium and nitrogen coming together to form one thing. One thing on the right means it's combination. Silver and H2S, Ag2S and hydrogen. We have an element and we have a compound. That means it's single. Letter C. It ends in CO2 and H2O. That means it's going to be combustion. More than one thing bonded together, that's a compound. More than one thing bonded together, that's a compound. We have two compounds. That's a double. And finally, you only have one thing on the left here, which means it's going to be a decomposition. I hope the summary really helped you try to figure out what you're supposed to be looking for when you're trying to identify these.